begin this second day with a masterclass. Allow me to introduce one of the most influential voices in human resources in the global semiconductor industry. Lynette, así es su apellido en chino, Deputy Corporate Head of Human Resources. ¿Lo he dicho bien? Sí. Gracias. Deputy Corporate Head of Human Resources at Taiwan Semiconductor Manufacturing Company, world-leading semiconductor company. With her, we will discover a global vision of talent in semiconductors, what large companies are looking for, what strategies work to attract, train, and retain talent. A real treat to start the day. Let's give her a round of applause.
Greetings from Taiwan. It's a privilege to be here with distinguished colleagues like yourself, and it's an honor to bring some sunshine and a breath of fresh perspective into talent incubation for the semiconductors industry. At this point, in this injunction of building out more fabs and answering to more needs, my company is focused on making things smaller so that our customers can dream bigger. We hope to bring to the world not only small chips, but we want to get into your home, get into your ear, get into your dishes, thanks to the microwave chips, and to be behind you with all your dreams in your vehicles. We have a clicker. Maybe it also has chips in there. We want to have 3 conversations today. First, I'd like to share a little bit more about TSMC and about ESMC, which is thanks to the dedication and wisdom and brilliance of Dr. Merced right here, who's mentored me since my joining the company 3 years ago. It's a privilege to be here to show her what we have done with her baby. Next, thanks to some colleagues in McKinsey and a few other places, PricewaterhouseCoopers, I will share some macro data on the talent dynamics in the broader landscape to contextualize our conversation of what TSMC hopes to contribute to the global semiconductor industry's talent pool and pipeline. First of all, TSMC was formed in 1987. Those who can read the words, it's a good test of your age and eyesight because I can't see a thing. But we have now a total capacity of around 17 million 12-inch equivalent wafers, which is quite a remarkable number. And as at our last quarter's earning, we have gone past the $100 billion mark. Thanks to currency exchange, we might just slip beyond that as well. We have now close to 89,000 employees worldwide, and we care about everything they do at work, everything they do at home. We hope to be a respected and loved company that will keep all of them in the industry. And you will hear more why that's the top focus of the human resources function in TSMC. Our mission is to be the trusted technology and capacity provider. Many of you would have heard this. We care about leading with technology leadership, with manufacturing excellence, most importantly, customer partnership, and to be the trusted technology and capacity provider. In short, we're here to stay. We have more than 520 customers, over 288 technologies, which, like I say, we keep making it smaller, and we hope to deliver all of that through our network of 24 foundries around the world. We're counting 24, but in reality, there are far more than that because there are more than, in some cases, there are 6 to 8 clean rooms divided up in phases in the different fabs. The Grand Alliance is our most powerful innovative force. We don't exist if not for our customers. And we can't exist without our partners all across IP, EDA, 3D fabric space, DCA, cloud, VCA space. This is our OIP, Open Innovation Platform Ecosystem Partners. And at this point, I thank them for their strong partnership and engagement with us to advance the global semiconductors industry. Equally, we are very focused on environmental, social, and governance. For me, particularly, it's very close to heart because we are and want to continue contributing to developing talent globally. I need to bring you some updates about what's happening closer to home. Maria, this one's for you. On 20th August, we broke ground in Dresden. We were really shoveling sand. We took some nice photos, but that's where it all just barely started. This is what it looks like about 3.5 weeks ago. I could have brought a more recent photo, but I didn't have time because Ponencias food and beverage was too enticing last night. So I got a little bit distracted. It's big. At the moment, we have 1,000 people on site, and they spread across 60 nationalities. At the peak, there will be 5,000 humans, warm bodies, talented people working on the site, constructing Europe's first ever fab for TSMC. We have clocked 11 million working hours on site. Apparently, we could have built quite a number of Eiffel Towers by this count. We've used a lot of materials: concrete, steel, waffle decks. Even more so, we have excavated more than 200 Olympic-sized swimming pools, and you wonder where the soil has gone to. Even bigger, we will have more pipes, more ductworks, and 1.5 million meters of cables. That's a lot. The first supplier day was held because of our commitment to localizing our supplier network. And that is our contribution to the economy and the economic outcomes of where we are located. We have huge interest. 550 companies applied, and we are in active conversations with many of them, and they are not only German companies, but they are from the region as well. This is where we hope it will look like when it's completed. We're looking at active operations from 27-28 and active delivery production 29-30. I shall not make any commitments. What if it happens earlier? More importantly today, I'd like to bring to you something very close to my heart about talent. You can have a lot of soil, a lot of concrete, a lot of materials, a lot of money exchanging hands, but all of this can only happen if we have the right talented individuals at the right place at the right time, and that they want to stay. So let me share with you what my colleagues are telling me. My colleagues in McKinsey, one source of reference, is telling me that globally there's a talent gap of 400,000 professionals required in the semiconductors industry. And people and workforce remains the topmost concern of the semiconductor executives sitting in the room right here. It's keeping them awake, apparently. And most importantly, for me particularly, it's about new fabs being constructed. We require lots of talented warm bodies to be operating them, to making innovations, and to make everything smaller. We also have demographic transitions, and that's not new. I've been hearing about demographic transitions since my days in pharmaceuticals. I've been dealing with clean rooms in pharmaceuticals for 16 years, and that was an old story. So it seems like that has continued to evolve even into the semiconductor industry. So it's becoming a world universal, maybe galactic concern. Closer to home, what I'm hearing is that a fifth of the employees in engineering and manufacturing in Europe are age 55. It's a beautiful age, but I think they may also need to rebalance their lifestyles a little bit, and that's where we're starting to think about how we need to support them, enable them. And even closer to home, photos that you have seen, a third of Germany's semiconductor workforce will retire in the next decade. And that's still okay. But the challenge is that we are not seeing an inflow of replacement. We're not seeing enough STEM entries into the market. And by this, I wanted to clarify, it does not mean that they are not graduating. It simply means they are not entering STEM. And that's become something we got concerned about. I started noticing that trend about 3.5 years ago when I first set foot on the ESMC project with Maria. We were looking at birth cohorts, we were looking at enrollment into STEM programs, we were looking at graduation, and it's a little bit alarming for me. And even more so, if they were to join semiconductors, what the data is suggesting to me that if they join and then they decide to leave, they're not coming back. And that is worrying. It's suggesting that those who quit their jobs in the past 2 years are not returning to the industry. Obviously, this data is between 20 and 22. Take it from a direction of travel rather than the absolute numbers. Because I validated against other sources, the numbers are slightly different, but the direction of travel is consistent. And that is where, so I like data, so I checked 3 sources. You pick what you want to use. So what we're particularly concerned about is the talent gap reality. What do we need to do about this talent imperative? The demand is intensifying. We all know that. Many of you are close to the activity. There's an emergence of aggressive investments. And there is an urgent coordinated effort that is required to address the talent imperative. TSMC would like to make its contribution to the global semiconductor talent pool shortage, closing the gap, by making a few efforts, which I will detail out in a moment. Essentially, we need to address and entice more graduates into the system. We need to deal with, address, and support, enable an aging workforce. I don't like that word, by the way. It's too close to where I am. And a poor industry perception of what is it like in the semiconductors industry. And remember, the semiconductors industry is this broad. The business where I'm in the foundry business, is one segment of it. And in this particular segment, the lifestyle and the grit required, the tenacity required, is rather different. I will share a bit more in a moment. So let me share with a lot of pride and thanks to many years of laborious efforts from my colleagues. And the efforts don't come only from human resources. They come from our operations side of business, from the research side of the business, even from our sales and business development colleagues, where we jointly put together a series of approaches. To contextualize our conversation, I would like to focus on the segment of students that are fresh graduates from the bachelor programs, the master's program, and the PhD programs. As you can see, there's a variety. I need to show off this thing. There's a variety of offerings that we do, but today, in the interest of time, I'd like to dedicate oxygen to the semiconductor curriculum that we've put in place since 2019. I'd like to talk about an exchange student program that I ramped up in 2024 and a university FinFET program that's been put in place since 2021-22. So first of all, just to make sure I have not lulled you into sleep, I know I started early this morning, how many of you are aware of a TSMC semiconductor curriculum? Great, so this will be good sharing today. In 2019, TSMC put together a curriculum, and I will flip that through very quickly. This can be made available to you. I will give you my email address at the end, so don't worry about taking notes and all of that, don't worry. So this semiconductor curriculum is curated by TSMC from an enterprise standpoint. And it aims not only to support the foundry business and the different engineering realms that are required, it also aims to support IC design industries, our clients, our customers. What it looks like is that it has got 5 segments: intelligent manufacturing, equipment, devices, process, IC design, and all of this earns credits. So in the universities, they either receive lecturing panel from our company, from the enterprise. We send our professionals, maybe it's a lithography professional, or it could be a process integration professional, into the schools as alumni, as adjunct lecturers, and they can teach in the schools, and they can, the credits are due to the students. Or we do exchange programs, and in the exchanges, including practical training internships within our foundries, within our fabs, they earn graduation credits as well. So this is what it looks like, and we have rolled this out across 9 universities in Taiwan. I'll run through quickly. You can email me, I'll send it to you, not a problem. We offer this to the schools. They can use it, And at the end, if they were to run through enough credits, the students who undergo this program, they receive a TSMC and the university's jointly delivered certificate of accreditation. And with that, they get preferential talent acquisition status when they join our company. We have collaborated in a variety of different projects, even beyond the semiconductor curriculum, across all the schools globally. And there has been over 400 projects across 50 schools worldwide in 2024. This is a lot focused around advanced research, and it aims to add oxygen, give oxygen to talent incubation. In 2021, my colleagues noticed a gap in design kits that are made available to design houses. So what we started to do in 2022 was to put together the first ever TSMC N16 Accelerated Development FinFET program, and we started offering design kits to schools, to universities mainly, admittedly not primary schools. They may not know what to do with it. But that is to help them research and come up with even better design. By 2023, it was a full rollout with the university design collaterals, N16 and N7. We deliver all of this in Europe, closer to home here, through IMEC, and by now we have seen 150 university grants, 350 professors have adopted it, and 6,300 students have been trained with this collaterals. There had been 26 design tapeouts. I think that's a very encouraging number. So what is going to be available now? Click of, I believe there are colleagues from IMEC here, and all of you can make contact, and you can receive the FinFET design, be part of the FinFET design training ecosystem. We thank our service partners, and we thank our training providers, and we hope this is our first contribution towards one of our contributions towards nurturing semiconductor talent in this part of the world in design houses. Next, I'd like to talk about something very close to my heart, the Semiconductor Talent Incubation Program Taiwan. To do this, I have to give credit to the curriculum that you have seen before, and I will share a little bit more about the NTC Newcomer Training Center, in short NTC, that was established in 2021 in Taichung, the midsection of Taiwan Island. It's a whole building dedicated to classrooms, laboratories, lecture theaters, and all. The most important thing is that we have real machines in there, pried open, pulled open in a safe environment, where originally for our new engineers, that's why they're called Newcomer Training Center, newcomer to TSMC, only engineers will go in there and receive training. They're fiddle with the machines, they won't be worried about safety issues, they won't be worried about messing up the equipment, but they get to play with it and develop not only technical know-how, not only the theoretical knowledge, but also the psychological safety and the confidence required for them to step into a living, breathing fab to be able to operate the machineries with confidence, conviction, and know-how. I'll show you a little bit more later. But what essentially the Semiconductor Talent Incubation Program is about is we combine all these elements. First, we have the curriculum. Then we have the facility to train them. And then we went out and spoke with different governments, different schools, and started putting students through the washing machine. And then we added a practical training component to it. I'll break it down one by one for you. The Newcomer Training Center, like I said, is in Taichung. And what it offers is 4 types of training program to different job functions, but mainly equipment, process, control, and more importantly, the on-duty skills. So they don't only learn what the machines are about, but they learn what to do while they're on duty. How do they interact? What do they look out for? What happens when that buzzes? Who do you speak with? What if it goes wrong? How do you protect yourself? How do they practice to be safe? How do they take care of themselves in an operating environment? All of this are part of the curriculum. And we pull the equipments apart. I know there are many gigs here, so I'm sure you like to see the equipment list. This one's for you. It's not exhaustive, but it gives you a flavor of the kind of equipments that we literally cut open, pull it apart so that the students can play with the wirings, they can play with the equipment, and they can look at what a scanner really looks like. So to recap, this is more than a tripartite relationship. TSMC plays a brokerage role, and we broker between the two sets of universities, the sending set of universities and the receiving cohort in the receiving panel in Taiwan. And we also help to interact or facilitate dialogue so that there can be better funding arrangements so that we can skip the bureaucracy and the challenges for immigration, taxation. We can skip all of that if we organize ourselves well. And what it really means is a showcase here with what I've done with Germany. We started with the Saxony-Taiwan collaboration, where we have a bunch of schools through TUD, signing an MOU with the Taiwan universities for an exchange program. And the exchange program is beyond the semiconductor curriculum. It also includes language training, Mandarin language. It also includes cultural training. And when I break down the schedule later on, it will help you understand why we want the students to spend some time in the universities. And then we put them through the washing machine, next pit stop, TSMC Newcomer Training Center. So this was incepted in 2024, and by now I've seen 3 cohorts. We are finishing up probably the 101 students. So each cohort is between 30 to 60 of them, and we have had 3 cohorts in Taiwan already. All of them become eligible to apply for jobs with TSMC, and they get preferential evaluation and support through the system. They can apply for roles in Dresden, they can apply for roles in Taiwan, in Arizona. It is really a global incubation pool. But Lynette, what if they don't want to work for TSMC? We are equally happy that we have contributed, and we are very supportive, very happy for them to be working for our partner industries. This is a 6-month exchange program, and we first started off being, like I said, being funded by Saxony, but we have progressed on. Berlin has put in more funding, and we should be seeing an acceleration of this program. We are also speaking with some other sovereign states, and there has been interest from various countries. They go through a 4-month exchange program where they receive a semiconductor module. You remember the 5 modules, they pick one. And then they get Mandarin courses, and they're encouraged to take anything else within what's offered from the schools. They stay in the university dormitory, so they're in a safe environment, and they're mingling with Taiwanese students. I'm pleased to report that of the 3 cohorts, 1 of the students have found a Taiwanese girlfriend. So this goes on for 4 months where they get intercultural exchanges, they start to understand the Taiwanese culture, and we hope they will fall in love with it. And that is very important for us in TSMC because we're keen to be doing knowledge transfer, technology transfer in all the overseas fabs we are building. And for that to be an efficient and effective process, there needs to be mutual understanding and friendship. And this is where we can address the cultural, social norm aspects through the school's environment. And then they go in 2 months of practical training, first 4 weeks in NTC, where they are feeling safe, and the next 4 weeks for practical training in a living, breathing fab. Showing you the slides are not good enough. I have something live to show you later on. Well, semi-live. When they graduate, they get a certification of completion, and they may be offered employment at any TSMC affiliates. This is the practical training plan. They go through equipments, components, process, and common processes training over 4 weeks in NTC. And then they go into a fab, they spend time looking at it, they stand next to a buddy. Everybody's assigned a buddy, and they can stand right next to a buddy fixing a real machine that is running, living, breathing. The students obviously cannot get involved in that process because it's our commitment to our customers that it will be flawless, it will be no defect, and all of that. Quality reasons, good manufacturing practices, students will be by the side, but they can ask questions and they will be provided with honest, authentic, and empowering responses. So they learn all of this, and they also participate in presentations. So you see, they get hands-on experience, they look at demonstrations, they work in groups, and they actually work on solving real-life fab issues. Here's a bit more perspectives for those who are familiar with the industry and are keen to see what do they actually fiddle with. It gets real. They are in a fab and they play with real machines, not toys. They go through 4 weeks of this, they complete a group project, and they will graduate. At this point, let me show you what it really means to them. Maestro, please. Can we play the video, please? It worked brilliantly this morning.
TSMC being the largest semiconductor manufacturing plant in the whole world, providing a once-in-a-lifetime opportunity basically to go into a real fab.
When I got to know about this program, I was really motivated to be a part of such a big organization so that I can improve my skills.
This is a really nice chance to figure out how I could potentially contribute to this industry in the future.
And this is I think, great opportunity. You can't say no to this chance. Once in a life chance to visit Taiwan.
In your first semester, getting the opportunity to do your internship at TSMC. So it was like a dream come true.
你好，
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 大家好，很高兴认识你。Hello， Dankeschön。
Today is you guys are entering an environment full of fab language. We have specially picked some lecturers to give you training, and those lecturers actually are experienced and talented engineers in our fab. And also you will be working very closely with your buddies, and your buddies who will be providing you the daily guidance and support.
I really like the buddy system. I think it was a great idea.
It's a really, really nice thing to know them, to understand how they are working in their daily life.
Every time there was a person who was responsible for us, we can go to and ask questions.
NTC provide a safe environment for newcomers, and we have mentors to help them study. And also we have courses for senior engineers for capability improvement. We hope that we can share some TSMC culture to them. For example, like ICIC, and hoping that they will have motive to join TSMC in the future.
So today class was about gas delivery, and we learned about different pump systems that has been used in TSMC fabs. We see the working, how does the pump work.
We can help them to develop interest in semiconductor manufacturing by transition from theoretical concepts we only read on textbook to a real-life experience. They are amazed by the effort we put into fix their problems, and in the end of the day, we pretty much enjoy our learners and the teachers.
Mostly the Fab 15A part was really nice. The transition from classroom to clean room was done so nicely. I really loved how all the engineers were so involved in taking us to the clean room and then explaining all the details about the tools and how the process is being carried out. That's the best part about the program.
You get the chance to see all the tools and how they function, and you have nice teachers. So yeah, it's going pretty good. Yeah.
Most memorable part is to see the fab for the first time, to actually see all of that running at an incredible scale that is hard to grasp. by yourself. It's just like a really intense and really stimulating experience for the first time.
I actually learned a lot about the work and life culture here in Taiwan. So as I already said, Taiwan, very, very lovely. Really fell in love with you people and just your life in general. This is really nice.
I had the most amazing time here at TSMC. Every team had put in their all for the success of this whole program. I want to give a huge round of applause for our buddies.
The best part about TSMC is they are always asking for feedback, but whenever we give some feedbacks, they change it the next day.
I really was surprised how friendly all the people are. They are so welcoming and they give us so much help and support.
If somebody is interested in the program because he is interested in semiconductors, I think you can benefit a lot from the program, and it was well organized and you get a lot of support, so I don't think anybody needs to be scared of this big step of moving on the other side of the world.
台积电碎啦！
台积电赞！
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 Programs like this are meant to inspire our students. They're meant to inspire them into the industry and into a foundry, into a fab. Because I think in schools, you learn about the amazing things of mechatronics, you learn about the amazing things that happen in chemistry, but what really does it turn out to in a fab? And this provides the showcase, the window for them. And what we hope this would help them find themselves. From the batches that have graduated from these cohorts, we have seen them returning back to pursue their masters rather than finishing at the undergraduate program because they feel that they need more and they've got inspired and interested. We have also seen very small numbers saying, this is not for me. And I think that's okay because we really want them to enter the industry with that deep love that all of us have for this industry and to find themselves and to grow their future careers. And to do that, once that, I used to say jokingly in HR, right? This is the time when they are not in the building yet. And then when they get into the building, what do we do with them? We support them through their career progression, not only with technical training, but we help them develop personal, effective work habits, ways of working. They learn the culture, they learn supervisory skills, they learn to be a first-line manager, they learn to be a team leader, and we support them through their leadership careers as well. Because you don't just transition from being a technical expert, a guru, into a leader overnight. And as a company, we have leadership programs, first-line leadership programs, middle manager programs, senior leadership programs. We mentor you. We provide shadowing opportunities. We provide coaching support. And we provide feedback. And we provide skills of the trade, as well as leadership skills. All of this are meant to inspire and retain employees in the semiconductor industry in our company, obviously, but we also create ecosystems where they can partner with clients, with customers to develop and pursue research opportunities. They get to go into schools to lecture and educate and nurture the youth. We provide all kinds of opportunities with the hope to curate, nurture more of them joining this industry and contributing not just in the fab with us, but to our customers and with even outside the broader ecosystem with our vendors. So we have a big hope and dream that what we are doing will bring semiconductors to the next leap of heights, the next pinnacle. On this note, I'm happy to reserve the last 10, 12 minutes for interaction. If there are any questions I can answer, I'm right here. No questions? I'll give you 10 minutes back to immerse in the forum. Thank you. Yes, please.
It's related with the Dresden University that visit you. How many universities or programs
11.
led that?
11 universities. A network of 11 from all over Germany.
All over Germany?
Yes.
And you are planning all over the world?
It depends on the interactions with the different government officials, different funding sources. Our doors are open.
Okay, I'm sure that locally you would have.
Yes, our doors are open.
Sorry? Ongoing. Thank you.
My pleasure. We're good? I shall leave here instead this. That's the slide to take the photo of in case you need to make subsequent follow-ups. My colleagues and I are happy to be of support. Thank you.